No new lesson today. We are at the end of Chapter 3. Thought we could work through some of the review questions, get some help on those in preparing for our test. Remember, there is going to be a test on memorization of the postulates, theorems, and definitions and such. End of the chapter has this page for you. You'll have to look through the chapter for the definitions. Memorize these Legos of our geometry so you can use them as we move ahead. So, very large array, radio telescopes in New Mexico. Pretty weird, but they're set up according to a pattern. I can see a few things there that we might be looking at. We've got some points in a line there, maybe between us of points. The definition of their coordinates, maybe between us of points theorem. Looks like we've got some angles in there. I'm seeing a couple of obtuse angles. Any supplementary angles in there? Doesn't look like it. Linear pairs, vertical angles. All this is in this chapter. Suppose the centers of the dishes along one track are in line, say this one, and have coordinates shown below. Here they are. There are the coordinates. There are the points. Is F between E and H? Is F between E and H? Before geometry, you would say, well, yeah, obviously, it just is there. It's between them. We want to use the definition to explain why that is. So look back at the definition of between us of points. Which is closer to C, point B or point D? Here's C. We've got point B and we've got point D. They look pretty close to the same. We'd be using the ruler postulate here. Part of it that reminds us that positive number differences measure distances. Is E midway between A and I? Again, midway would mean it would be a midpoint, which would mean it would bisect or divide into two equal parts. So think of the ruler postulate to get those distances to see if we are in the middle. Here's an interesting tool that can be used by carpenters, and I suppose anybody trying to transfer some angles. There's a little screw there that you can turn by hand, and it will adjust these angles here. So if you were going to put it up against an existing angle, you could get that angle figured out exactly. Then you could transfer it to another piece of wood. You can see this thing can turn, so these angles could end up being pretty much any amount. Here's a given. Regardless of the angle BEV and VEL always form a linear pair. That is the given. Remember the definition? They have a common side, EV is in both of them, and their other sides, EL and EB, are opposite rays. Some questions now. What other relation do they have besides being a linear pair? If BEV is x degrees, what would VEL be? You won't have an exact number. It will be in terms of x. Don't forget your labels. If BEV is larger than VEL, what type of angle would BEV have to be? How about VEL? As you think about that, what if EV was perpendicular to BL? What would they both be? Moving on, if BEV is equal to VEL, how large is each angle? I guess I just asked you to think about that, but that helps you with number 6 too. If BEV is equal to VEL again, what can you conclude about the handle? This handle in relation to the blade is what he's talking about there. And then for review, find the theorem. This was the hardest one in the chapter to keep straight. But it has to do with if the angles of a linear pair are equal, find that theorem. So an astronomical quadrant. They can line this up with the ground, and then they can line it up with a star, and they can get different angle measures in here. In this particular case, we've got several rays here, CE, CS, and CD. with that common vertex C. And we're given some coordinates or names for those rays. We're not given this one. We've got D and E. We want the measure of angle ECD. Now we're not on the ruler postulate anymore. We're on the protractor postulate. So check that out. It's used to measure angles. A review of the symbolism. How do you write the fact that CS is between CE and CD? CS is pointing toward the sun. It looks like it might bisect ECD. ECD, you see that one here? It looks like it might have bisected it or divided it into two equal parts. If it did, what would ECS be? What would its measure be? Okay, you have to go back to number 10 to help you out there. What would the coordinate of CS be? So now we're looking for this coordinate up here, which once you calculate the angle measure, you can see how that coordinate has changed. Check your work by using the coordinates of CS to measure SCD. So now take this coordinate you just got, use the coordinate 18, and see whether this angle ends up being the same as this, which we suspected it did, as a bisector. Ali is at it again. He said either two lines intersect or they do not. That was his given. Then he reasoned, if they intersect, they are perpendicular. If they don't, they must be parallel. Overstated things here a bit. Alice is always double checking Ali's reasoning. And she says, once again, Ali, nonsense. Question is, does anything that Ali said make sense? If so, what would that be? Apparently there is at least something wrong. Alice disagreed with him, and number 16 asks you to tell what is wrong with his reasoning. We have an SAT problem here. I would encourage you, well, I guess they tell you to in 17, copy the figure. A lot of people just put their paper up there and trace it. Nothing wrong with that. Put in the coordinates 0 and 70. 0 on ray OA and 70 on ray OC. Use the other givens here about the angle measures to get the other coordinates and the measure of BOC. Getting practice with betweenness of rays and protractor postulate. All right, I don't know how you lace up your shoes. Looks like they're going under and then over. This one goes over and under, so alternate that. It's created some angles here. 1, 2, and 3 are labeled, 3 being this one a little bit in the bottom here. Got angles 1 and 2 here. Now they're asking you about those two angles. Two ways that they are related. If they were complementary, so go into the definition of complementary, remind yourself of what that is. How many degrees would each have to be? And why would that be? What kind of angle pair is angle 1 and 2? If they were supplementary, now we've got angles 1 and 2 and we're saying they're supplementary. Remind yourself of what that is. They're still vertical angles, so they would still have to be equal, wouldn't they? So the question on 23, what would be true about AD? Now they're looking at the laces themselves. So if this were true, what about AD and BC? If 1 and 3 were supplementary, if 1 was supplementary to 2 and 3 was supplementary to 2, then what would have to be true about angles 1 and 3? And then a reason why. All right, a Chief Justice of the Supreme Court for many years once said, "The law embodies the story of a nation's development through many centuries, and it cannot be dealt with as if it contained only the axioms and corollaries of a book of mathematics." Too deep to consider right now, but he uses two words in there, axiom and corollary. One of the axioms of algebra used in geometry is reflexive property, stated as a sentence. You should probably try it without looking and then see how you do. See if you're ready for the test. A couple of more here. An angle has exactly one ray. Complete that corollary. And a third one, all right angles. Complete that corollary. Bringing back some clock problems from an old geometry book here. How many degrees are there in an angle formed by the hands of the clock? So this one right up here, this angle. It's an acute angle. And this one, let's see, I would say it's 5 out of 60. And if there are 360 degrees around, so 5 over 60 is x over 360. Come up with a number there for that one, but that's not what they're asking. What if it's 5 o'clock? If you answer the one I was doing, it will help you. So if it's 5 o'clock, what would the angle be? If it were 10 o'clock, what would the angle be? Continues on. If you reasoned that 10 is twice 5, you might think that the second answer should be twice the first. How can the second answer be correctly obtained from twice the first? Think about that a bit, and then draw a figure to show both times on the same clock to illustrate your answer. Interesting problem there. So here we've got fun and games back around the time of the Revolution. And they're walking around on stilts. It's either a race or a, who knows, chicken fight. So a person 6 feet tall, this would be F for their feet, H for their head. And they're on stilts that are 6 feet tall. So from there, T to S is 6 feet. The cleats are X feet above the ground. This is the number we don't know. So these are some marking up the slide here a little bit differently to help you see that. And that's what we're wondering about. So how tall in terms of X is the person when wearing the stilts? Use the givens over here on the left. How far in terms of X is it from the top of the stilts to the top of the person's head? This distance. Look at the equations you've done. Think that one through, come up with the answer. And here's a little proof now, working that through. Please note the copy incomplete. We're given F is between S and T is between F and H. The point of that is to show that these are straight lines, that those points are collinear. That allows us to use the betweenness of points theorem. We also have that ST is equal to FH. So ST equal to FH, as we saw earlier. We want to prove that SF is the same as TH. That's our thought. So you're supposed to give reasons for these proofs. First of all, we've got some points that are between others. Looking for a reason. Now once we know it's between, we're suggesting that SF plus FT equals something. Fill in the question mark and then give a reason. It's the same reason for FT plus TH being equal to something. Question mark, same reason. They think we can go from step 2 here to step 3. So what's the difference between those? Remember to look up here in the given. ST is FH. Now, using 2 and 3, somehow we've gotten to 4. How can that be? Well, I'm going to go up here. I see SF plus FT, and I've got that down here. Here I have FT as TH, and I've got that right here. Why can I say those two have to be equal to each other? Look through your answers to 2 and 3. That'll get you there. Looks like this is the last step here, so what would have to be in that last step? SF is TH, and I want to know why. So look at step 4. How can you get from step 4 to the proof step? Never wanted to be a crash dummy. Here's an example of one being used to determine if a chair is comfortable. They say it needs to be slanted from 5 to 8 degrees from the horizontal, so that's this little up here, and tilted 20 to 25 degrees from the vertical to be most comfortable. Here's a diagram going to follow, and OA and OB are the seat and back of the chair, with VT perpendicular to HZ as marked. VT perpendicular to HZ. And these are our givens here. Angle 1 is X, angle 3 is Y. So now with those givens in mind, find the answers to these questions. 2 in terms of X, and angle AOB in terms of X and Y. And here's a proof. Copy and complete an indirect proof. Right away your head has to say, what am I trying to prove? Suppose the opposite. Proof that a comfortable chair AOB cannot be a right angle. So you can have a nice right angle chair and be comfortable according to the givens on the previous slide. So look through each step and fill these in. It is a copy and complete, so don't miss that. Beginning assumption and give reasons now. We're still going, well, angle A is 90, 90 minus that. So how do you get from one step to the next, and so on? Working our way down through this indirect proof. They actually give you the contradiction this time. This contradicts the fact that X is between 5 and 8 and Y is between 20 and 25 and Y is not equal to X. So in this process, somewhere in here, we've got a contradiction. Therefore, our assumption is false, and what follows? Copy and complete the following indirect proof for a comfortable chair. AOB cannot be a right angle. I think we just did that. Now, according to the chair design rules on page 126, I moved them here, can the back of a comfortable chair be perpendicular to the seat? Look back at what you just did. Here's a fun SAT problem. A, B, C, and D are points on a line with D, the midpoint of segment BC, there's a given. The lengths of the segments are as follows. AB is 10, AC is 2, BC is 12. Draw a figure to illustrate what is being described, and then what is the length of segment AD. So you are using the betweenus of points theorem here, and the ruler postulate. So sketch that out, give it a try, so you can get all of these givens worked into that picture. Moving geometry right into now, we've got geology, rocks and minerals. Although both graphite and diamond consist of carbon atoms, the different geometrical arrangements of the atoms in them give minerals very different properties. So here are the carbon atoms, flat sheets, the points are atoms, the segments are the bonds, all of the atom angles are equal. So what kind of polygons do you see, and how many degrees would need to be in each one? This is how do you think, but you need to be able to figure this one out exactly. And here's a proof dealing with those. This is our given, that 1 plus 2 plus 3 is 360, and all the angles are equal. So this is to try to help us figure out what those angles are. So some statements and reasons, and you are supposed to come up with the reasons for that. So here's the diamond. Different, hardest mineral that atoms are arranged differently, and that has something to do with it. The green segments have been added to make it look more three-dimensional out here rather than flat. Here we have an indirect proof on those diamonds. We're trying to prove that AOB and BOC cannot be a linear pair. AOB and DOC are not a linear pair. BOC, I guess it's this one. This angle here and this angle there. They kind of look like they are, but we're proving that they cannot be a linear pair. So how are you going to start? And they get you going here. Probably giving you a hint here, right? Suppose they are a linear pair. If they're a linear pair, then what's true? And so on through here until you reach the contradiction and decide what must be true. Because AOB and BOC cannot be a linear pair, would it be correct to conclude that A, B, and C are not coplanar? We have these 3 points, A, B, and C. Not a linear pair, does that mean then they're not coplanar? And explain that. And then finally, military marching, quick time. We've got some questions about this. 120 steps, each 30 inches long per minute. So that's quick time. And they measure it and they make you do it exactly right. So here's a timeline and some questions about that. Okay, work these through. Bring any questions you have to class, and we'll work them through.